Okay. How much time left? So where were we? Mesh folder settings. So let's open this. Yeah. So we already done all of this. So we need to change solver settings. So let's go to the Home tab, open Setup Solver. So here, first we're going to use tetrahedral mesh. Typically, it's better in terms of so for tetrahedral mesh, you need just minimal 4 cells per wavelength. And in hexahedral, you need if you use hexahedral mesh, will be much larger. So typically, tetrahedral is better. Now, method, we will use default method. It works only for the systems with kind of closed systems. Closed systems, that means that the frequencies, eigenfrequency is real. So general method is used for the open system or systems with losses. So in our case, we do not have any losses or open channels for the radiation to leak. So default method, a number of modes. We're looking to find eigenfrequencies of the first two bands, which are two modes. But they are also degenerate in polarization. So maybe let's set it to 4 to make sure. Okay, and the last option, there is by default, it's used this adaptive mesh refinement option. It's not very convenient option, so because the CST will change, so it will make a simulation, then change the mesh, so increase the number of mesh cells, do one more simulation, one more, and so on, until certain criteria is satisfied. But it's not very, so CST is good for your problem. So by default, it's not very good. So just remove this option, refine tetrahedral mesh. Okay, the final thing that we need to change, after that we can start simulation. We need to set parametric sweep. So since we are interested in the dispersion, maybe not in the whole Brillouin zone, yeah, okay, but at least somewhere close to the edge of the Brillouin zone. So close to the phi equal to 180 degrees. So we open parametric sweep. You can do it either from the setup solver or in the home tab, find per sweep. Add new sequence, new parameter. Choose this phase difference as a parameter and change it, let's say, from 100 to 180 with the step with, let's say, 10 degrees.
The number of samples or step with?
Well, it doesn't matter. Something like, yeah, step with 10 or number of samples. It's not very important. So after that, click OK and start simulation. Start simulation from the parametric sweep dialog box. No, not necessarily from 0, because we're mostly interested what's happening close to pi, to 180 degrees. So pi here is in degrees, yeah. So change it somewhere from, let's say, from 100 to 180. And after that, click Start. So once the program starts simulation, you can already open 1D results folder, mode frequencies, choose all these modes.